squares are shaded in the 8 by 8 grid? Well, what we can do is, if it's an 8 by 8 grid, then there's 64 of those squares, and we can count them all, or we can count the ones that are not shaded, which is just 8 and 7, which is 15, and then subtract from 64. Either way, if you do that, it's 49. There's also, these are all 7s, right? So it's 7 times 7 that are shaded, so 49. Either way, you get 49. So number 2, the answer is E. A rectangle is divided into 2 vertical strips of equal width. The strip on the left is divided into 3 equal parts, and the strip on the right is divided into 4 equal parts. Parts of the rectangle are then shaded as shown. What fraction of the original rectangle is shaded? So instead of using x's and y's and all that, I'm just going to use numbers. This makes it easy. And I'll use a number that is going to divide evenly by 3, by 4, by 12, whatever, by 2. So I'm going to say that the total area of this entire shape is 24. So let's go back to the question. They divided into 2 equal vertical strips. So this vertical strip is equal in area to this vertical strip. So that means both of those have an area of 12. Okay, these are the areas of those vertical strips, 12 and 12. 12 for this guy and 12 for that guy. Now, in this first one, they divided into 3 equal sections. So each of those will obviously have 4 divided by 3 as an area, which is 4. So this is 4, this is 4, this is 4. This one, they divide into 4 equal sections. And if you do that, each of them will be 12 divided by 4, which is 3. 3, 3, 3, 3. So now we just have to count. The fraction of the original rectangle that is shaded, well, it's this plus this plus this plus this. That's the shaded parts. So that's going to be 4 plus 4, 8 plus 3 plus 3. 8 plus 6, 14. And we have to divide by the total, which is 24. And that's the answer to the question. Of course, they're going to lower it to lowest terms, 7 over 12. And that would make number 8, choice E. The rectangle showed has sides length of 8 and 4. The area of the shaded region is. This question you can easily sort of figure out by just drawing a line from there to there. And then noticing that what we've really done is just taken each of these rectangles and then cut them in half. Same thing with this one here. We've taken that rectangle and just cut it in half, because if you notice, the line goes all the way from one corner to the other. So what that really means is that the shaded region is really just half of the total region, because if you just looked at that rectangle, this shaded region is just half of that rectangle. If you look at this rectangle, this shaded region is half of that. So all I have to do to figure out the total shaded region is figure out the total area and then divide by 2. So that would be 8 times 4. That's the total area. And then divide by 2. That's the area of the shaded region, AS. So 8 times 4 is 32, and then divided by 2 is 16. So number 10, the answer is B. In the diagram, the center of the circle is O. The area of the shaded region is 20% of the area of the circle. The value of x is. X over 360 degrees is going to be the equivalent area if you compare it. And they've already told you that is equivalent to 20%, which is 0.2. And there you go. That's what you have to solve. So x is going to be 0.2 multiplied by 360. And that is equal to 72. So number 6, the answer is D. In the diagram, the rectangle ABCD, the area is 40. The area of MBCN is. So that's the shaded region. All right, let's blow this up just a little bit. First thing I think I will do is I'll draw a perpendicular from N up to the top right there. And then since that's a perpendicular, I can use that to figure out the area. Now, From here to here is 4, and from here to here is 2. So that means this is 2 also, and therefore this distance is also 2. And then we have to, of course, figure out the distance from B to C. We do that because they tell us that ABCD has an area of 40. So ABCD, that's a rectangle. So length times width is 40. The length is 8, right? From here to here is 8. Times width is 40. So dividing by 8, we get width is equal to 5. So that means BC is 5. So that's 5 and that's 5. Now we can figure out the area of the shaded region, which is MBCN. And that's first this rectangle, which would be 5 times 2. And then add to that this triangle, which would be 1/2 base 2 times height, which is 5. So we got 10 plus 5, and that is 15. So the answer is 15 to number 9, and that would be choice A. A rectangle has a length of 3/5 and an area of 1/3. What is the width of the rectangle? Well, area is equal to length times the width. The area they have told you is 1/3. The length is given as 3/5, and now we just have to figure out the width. So cross multiply, and this gives you 1/3 is 5/3, like this, for W, and therefore the width is 5/9. And number 5, therefore the answer is B. In the diagram, square PQRS is divided into 4 identical squares. What percentage of square PQRS is shaded? Okay, well, there's 4 squares and only one of them is shaded. So 1 out of the 4 is shaded. And that, in terms of a percentage, is 25%. So number 3, the answer is C. In the diagram, square PQRS is 3 by 3. Points T and U are on the side QR with QT equal to TU equal UR equal 1. Points V and W are on side RS with RV equal to VW equal to WS equals 1. Line segments TX and UY are perpendicular to QR, and line segments VY and WX are perpendicular to RS. The ratio of the shaded area to the unshaded area is... Well, I'm sure you know how to do this the long way, which is just figuring out the areas. I'll show you a quick way, which always helps since on math contests your time is limited. So, as you can see, what I did was I cut that into smaller squares, 9 of them. And all we have to do now is just count the number of shaded small squares and unshaded. So when they're asking for the ratio of the shaded area, area of the shaded region, to the area of the unshaded region, area of the shaded region, well, it's this square, this square, this square, that, and that. That's 1, 2, 3, 4, 5, 6 shaded squares. The unshaded squares are these guys right here. There's 3 of those. And that's it, 6 to 3 or 2 to 1. So in a very quick way, you can figure out that. And number 10, therefore, is A. In the diagram, triangle ABC is isosceles, and its area is 240. The y-coordinate of A is... So the first thing I want to draw is a perpendicular from A down to the base there. And since this is a isosceles triangle, it will cut the base into 2 parts. Now, I don't know if that's important for us, but I just wanted to mention that. So now the area of that triangle ABC, they tell you, is 240. Now, how do you figure out the area of a triangle? Well, 1/2 base times height, as always. And the base in this case is from here to here. And what is that distance? Well, it's the x-coordinate of C, 20. And there you go. Now we can figure out H. So we got 10h is equal to 240, and therefore h is equal to 24. So the height, this green line represented h, and that's 24. So that basically means that this point, the y-coordinate is 24. And just in case you're wondering, the x-coordinate is 10. How do I know that? Because this green line cuts the base into 2 equal parts, and the whole part was 20, so half of it is 10. So y-coordinate of A is 24, and therefore number 6, the answer is D. In the diagram, what is the area of triangle ABC? So let's blow this up a bit. This is going to be essentially dependent entirely on the coordinates. So if this is the height from top to bottom, that distance is the y-coordinate of A, and that would be 9. So 9 is the height of this triangle, and the base is from there to there, which is the x-coordinate of C, and that's 12. So therefore the area is 1/2 base times height, like that. And that looks like 6 times 9, which is 54. So 54 is the answer to number 8, and that is choice B.